So what we want to do is called related rates. Okay. I try to, in the textbook and even in the syllabus, they kind of divide the application into three. I try to split it into four so that we can see different area. As a matter of fact, kinematics was not included in the application for differentiation. It was discussed in the integration. But it would be nice if I could extract the differentiation aspect first so that it's not totally difficult when you get to integration. For example, we know that the velocity is going to be ds dt, right? So in integration, we will tell you that this is going to be the integral of the velocity because integration is opposite of differentiation. So this is what we will discuss more for the IB exam, but it would be nice to have this idea. Questions on this are not so much, but you see questions on this a lot. Or in some cases, the same question would involve both of them. So there's no point giving you the question now when you have not done integration. So that is why I took some sources like WAEC, my own country exam, and some other ones. So we have an idea ahead of time. Another thing is that the rate of change and related rate are not, related rate especially has emphasis, not the normal rate of change that we have to discuss first. So sorry if I took too long, like extended everything to like 4 stages. It was necessary. So this related rate, as the name implies, you're not just talking about the rate of change that we discussed in application 1. I think that was application 1, rate of change. Or was it application 2? That was 2. Okay, kinematics was 1, this is 2. So we're saying related rate because we are dealing with 2 different variables now in the same situation. So while the rate of one is increasing, we are interested in the rate at which the other variable is increasing or decreasing. Okay. For example, this question says, find the rates, the area of the circle is increasing at this rate. So this is the rate of change of the area of the circle. Now the question wishes for us to study the rate at which the circumference is changing. It's the same circle we are talking about. All right? We know the rate at which the area change increases. Maybe when we expand the radius, right? At what rate is the circumference changing? So for example, if I change the radius from 4 to 5, if the area increased by certain x%, what happens? At what rate is the circumference also changing? It's definitely going to increase also, right? Because the more the radius, the more the area, the more the circumference. Is that not? So that is what this application is about. So I'm starting with 2 simple cases. Next time we'll take a whole class, and maybe towards the end of next class I might introduce the last one, or we wait till Friday and discuss the last one, depending on how the class goes. So let's see. And like I said in the introductory, I said rate of chain rule is very important here. Because chain rule allows this that looks so complicated, so easy. Now, this is what you know. The A, the R, no, the A, the T. And you see, even from the unit you could see, rate of change of the area with time, that's the A, the T, right? It's given as 4. You know that your radius is 6. That's what you know. The question is asking for the what? The C, the T. Rate of change with respect to time. Okay, so you're looking for this. So the first thing you would think of is, how can I relate these two together? For example, I could have, I'm just trying to scribble something, I'm not saying it's official yet. So we can have the A, the T. It means I'm going to have the A, the something, the T. Do you agree? Okay? So if that something is R, then this will have to be the R, the T. Then you see if this can connect them. We have this one. Can we find the A, the R? Can we find the rate of change of the area with respect to the radius? Yes, we can. From the formula for the area, you can find the A, the R. Understand that? Then it means you can find this one. But this is not what we are looking for. Rather, this is what you are looking for. Then it means you are going to come up with another relation. This is what you're looking for. In terms of this, that would be what? The C, the R, the R dt, which you have already found here. Can this be found easily? From the formula also. So we are going to combine these two ideas to solve the problem. Do you understand what I just said? So you can see chain rule comes in handy here a lot. So from the first relationship, so we're going to say from area is equal to pi r squared. We're dealing with a circle, right? The A, the R will be what? Talk to me. 2 pi r. Is that enough? There's a reason you were given the radius is 6. Okay? So your dA, dr, when your radius is equal to 6, becomes 2 pi bracket 6. Am I right? Which is equal to 12 pi. The question says in terms of pi. Am I making sense? So from here, from dA dt equals dA dr times dr dt, it implies that dA dt is given for dA dr 12 pi, dr dt unknown. Can we see that? So this will be divided. It means my dr dt is going to be 4 divided by 12 pi. You have to be careful when you're doing this, so you don't write 12 pi divided by 4. And that gives us 1 over 3 pi. Am I making sense?
Could you explain that step again?
This step?
No.
This step?
What you just said. Yeah.
I just divided both sides by 12 pi.
Oh, okay.
Okay? I just decided to move this here immediately. Understand? So that's what I've done. Questions? Also, so we repeat the same process from the circumference, which is what? Again? 2 pi r. The C, the R will be what? Speak louder, please. 2 pi. I need those over there to talk also, and less from Lillian. I want to hear from others. This is independent of R, so we don't need to substitute R is equal to 6. Understand? So again, by chain rule, the C dt, which is equal to, remember, this is what we are looking for. Okay? The C dt, let's write the formula in terms of chain rule. Yes? The C dr, dr dt. Can you see that? So the C dr, do we know? 2 pi. The r dt, do we know? 1 over 3 pi. So what is the rate we're talking about? 2 over 3. What will be the unit? cm per seconds. Even though it says in terms of, oh, it doesn't say in terms of pi, so they know that pi is gone. Do you understand that? Sometimes the question is direct, in the sense that the question will just say, oh, the rate at which the area is increasing is this. Find the rate at which the radius increases. So which means you stop here. But this is now extended. Okay, use that to figure out something else. So that is why we are having 2 stages. I thought this was a 1 stage. I wanted the first question to be the simplest one. Unfortunately, I miscalculated, sorry. So let's look at this similarly. Here we are dealing with a sector. We're looking about area of the sector at the point, but we are looking at the rates of change. Wait, find the rate of increase of the area. Good. That's what we are looking for. But what rate are we given? The rate of increase of the radius. So before we write the official solution, we are looking for the rate of increase of the area. Is that not? By chain rule, that would be what? dA, dr, dr dt. Right? So what do we know? Which of them do we know?
dr dt.
dr dt. So this is known. Can we figure this out? Talk to me, please.
Yes.
From where, Kerry? From the formula. So this is actually should be my number one because it's a one-step solution. Do you understand? So then we go to the formula for area of sector. What would be the formula for area of sector?
Angle.
Yes? Anyone else?
Wait, say that area of a sector.
Yes.
Angle over 360.
Angle over 360, so theta over 360, yes?
Times pi r squared.
Pi r squared. If you are confused, this is how I learned it. Area of a circle is pi r squared, right? A sector is just a fraction of it. Okay? What fraction? If my sector is a quadrant, the fraction is 1/4. What determines this fraction? The angle. Understand? Oh, 1/4 of pi r squared. That is this one. If it is a semicircle, oh, half of pi r squared. That is this one. Everything. Right? So for a random sector, how do we determine this fraction? It's going to be, oh, the angle is sustained out of 360. This determines the fraction. So that is how this came about. It's just a fraction of the entire circle. Similarly, if you are talking about the length of arc, the length of the entire circle is what? 2 pi r. So the length of arc is a fraction depending on the angle also. If the angle is 90, this arc will be one quarter of this. If it is a semicircular arc, it's going to be half of this. Am I making sense? So for any arbitrary sector with any arbitrary angle theta, similarly, this length of arc will just be theta over 360 of this one. So you don't need to memorize the formula if you understand this concept. Understand? So quickly now, so we have from, I like to write what we know first, so it's easy to relate. The angle of a sector, theta is equal to 75 degrees. And we are using this formula and not the radian formula because you can see the measure is in degree. You have to take note of that, okay? What else do we know? The what? The R, the T, talk to me please, 0.3 cm per second. What else do we know? Radius. Okay? So we start from the area. Area is equal to theta over 360 degree pi r squared. So you can substitute this first, but don't substitute your radius yet until you differentiate. Because if you substitute already, that's what is the point, right? So we can, maybe we differentiate first, so it's uniform. The A, the R will be, this is a constant, do you agree? Then this will be 2R. Is that not? So giving us 180 now here. So basically theta over 180 degree pi r. Is that not? Then we can substitute everything we know. 75 degree over 180 degree pi times 6. Yes? Quickly please. What is that?
5 over 2.
5
over 2.
5 over 2 pi. Yes? What would be the unit of this?
CM.
That's like cm per cm, sort of. So, which is just cm. So let's leave that. Where's my, quickly, sorry. Because of our time. Before Mr. Long comes to arrest you guys. Okay, so quickly, by chain rule, let's put it together. Yes? dA, dt, because the ADR, and the R dt. So let's substitute what we know. Sometimes this is what is missing. This is what is missing actually. So it doesn't mean that's what you write first. Okay? So the ADR, we know that? Yes. No, the ADT. That's what we are looking for. Oh, okay, good. The ADR is 5 over 2 pi, and the RDT. So let's multiply. This is going to be 3 over 10. 15 over 20 is divisible. What's that? Speak louder, please. 3 over 25? 4? Right? 3 over 10 Oh yeah, 3 over 4. 3 over 4 pi. And that will be units squared per second. It says in terms of pi, leave in terms of pi. So this is an idea of what related rate is about. We'll take more complicated questions when we come next time. You can see already the 6 questions in your worksheet. See you next time.